Thanks, and so I'll rush through this. There's a lot of discussion about what's climate change and what's variability and so on, and this is a slide that I guess I use a bit to think about this. So you can have an argument with a kid on the seaside about what destroyed the sandcastle. Was it the wave or the tide? And in one sense you can go backwards and forwards. But in the end, it's usually a wave that destroys it, but on a rising tide, it will be the wave that does the damage. When I talk to farmers about this, sometimes people come up to me afterwards and say, I'm a bit of a wave man myself, all this tide stuff. But I guess I'm saying you don't really have that option. Waves and tides happen together. And so, yes, we have a variable climate. It is a stupid argument to say, is it change, is it variability, is it one or the other? We cannot distinguish these things. And there will always be a sterile debate. But I suggest, personally, I'm suggesting we have to be saying we're seeing both. And they're interacting in complex ways. I'm not comfortable saying, well, let's just talk about variability because it sort of is comfortable because it doesn't involve discussion about change. Because I think that we know that change is happening. That's very clear from the scientific community and so on. And I think there are many farmers, many in this room who've taken a leading position and said, yes, this is change and something is happening here. And I think it's important that we don't just leave them out to dry and go back to this notion of being variability. So I guess that's how I would see this. And one of the issues that comes with this are extreme events. So that is obviously weather. I mean, climate change we delivered to us through weather. And extreme events are a challenge for climate science in terms of understanding them. They're a challenge for impact science for exactly what the impact will be. And they're a challenge for decision making. So just very simply, we talk about risk as frequency and consequence. So how often something happens and what the damage it is. Sometimes we talk as if that's sort of an isoline of risk that you can move up and down. What people are rightly saying is that these are high consequence, low frequency events. Frosts, heat waves, cyclones and so on. They do a lot of damage and they're really hard to manage. They're really hard to think about. We don't have the frequency for them to happen, whereas low consequence, high frequency events. So sometimes people will talk about the trade-off between moisture stress that happens every year a bit into spring and then these frost and heat waves and so on. And in one sense, we have to think very differently about how to understand and manage these extreme events. That they are challenging all round. We know that mean temperatures are rising, and the most important part of this graph is that the mean decadal change is happening. But the Bureau will point out that what's really dramatic is the extreme events, and that and the number of very, very hot days is rising far faster than the mean, and that's what you would expect, even with just a normal distribution. This is a graphic from the Bureau of Meteorology. We tend to do a lot of talking here at the global warming. Obviously, that's in a long time, whereas local and immediate activities, but these are linked, and what happens up here translates down through here to these individual events. So we know that means are changing and extremes. These are temperatures at Minipa. This is, if you talk to grain growers in southern Australia, this 12th of October 2004 was this extreme heat event. And that really, I guess, shocked a lot of people at that time. You can see there the 5th of November, just after it, was a frost. So that's not unusual to be getting a heat event followed by frost. And then 2009, this cluster of very, very hot days in November, big impact on viticulture and big impact on later areas. And you can see these very, very high minimum temperatures. And again, a lot of the physiology of crops and so on, and some of these very, very hot nights are very important, as well as the hot days. The number of hot spring days at Snowtown near here, you can see that there is an El Nino effect. So in El Nino years we get more than La Nina years. So we have some understanding of that and so on. We have an understanding of what drives these general weather. So this is February in Adelaide, that's where you are now. What we're experiencing at the moment is this distribution. So really southern southern summers are really about where you are in the high pressure system. Initially you get a high pressure system coming across that brings a southerly flow into here. Cool, lovely days. Then the high pressure system moves across you. You warm up a bit. Then you get a tail at the end. And sometimes this gets blocked in the Tasman. And that's when it gets nasty, and that's the sort of heat waves and so on. So these are pretty well understood, that the high pressure systems will always sit either in the Bight or the Tasman, and they'll move fairly fast across this time. And so you can actually see that February weather is actually just a combination of where those are sitting. The big understanding is where's that blocking happening, and will that happen more in the future, or will we just get the same weather system with the climate, so the tide just rises a little bit, and how that will change. What we're doing partly is to torture some wheat plants in the field with a little chamber. It's a Kmart heater, and we're heating it for just a day, up to 35 degrees for just that day. And this was last year. Was that there was a 25% reduction in yield from just one day of that event. This year we only got a 10% reduction in yield for the same sort of time, and I think that's a bit to do with being a milder year this year, and just variability and so on. But some of these events can cause significant damage. So we're creating a bit of global warming with it by burning a bit of. So it's alarming how much petrol you got to burn to keep a little $15 Kmart heater going. But that's what we're doing and trying to measure that. And there's the famous Kim From, and I guess this is a link to Climate Champions. And what's worked really well is having Kim come and talk to us about real heat waves that he's dealing with in terms of what we're happening here. So coming down to Adelaide and talk to us, and those links and so on are really important. And there's Glenn McDonald, and I'm showing Kim a new dance. Now I'll quickly go into the issue of frost. So that's perhaps the other side of that. So this is Steve Crimp, who's working on frost risk in a variable and changing climate. And Steve is based in CSIRO in Canberra. So just this very simple point that although we would be expecting frost to be getting less, in southern Australia we are getting in many cases more frosts. So while we would expect there to be fewer frosts, with warming we're getting more frost in many locations. So this is the classic diagram. This is for emerald. The bottom is the date of the first frost and the day of the last frost, and they're crossing over and they keep going. We'll be getting the first frost before the last frost or something. But in emerald there's this dramatic case of that sort of channeling in. So the frost period is changing. However, when you go to Morawara in Western Australia, you see it's much flatter. See Bendigo, it's doing the opposite. If you like, the frost period's getting longer rather than shorter. So you knew global warming was rubbish. And there's Wagga Wagga, okay. So you can see that this is happening when mean temperatures are increasing, yet these spring events are changing. Much of this is probably to do just simply with over that period from as Hiram has shown, we've just had much drier springs, and the two are related. So this is what Steve is working on. This is the high pressure systems. This is the anomalies. So as you go to that yellowy colour, we're getting more high pressure systems. So we're getting more high pressure systems in this band, and the southern bits are even getting stronger. It's not saying it's necessarily shifting south, but the intensification of the pressure systems are getting higher. We're getting more high pressure systems, and they're getting higher, which is what you'd expect with a drying trend. And the southerly displacement, but one of the important points is that it's not so much they're all moving south, it's just that the southerly ones are becoming stronger. This is for the spring period, this really vital spring period. And so I guess very briefly here, what we have is a high pressure system. This is the anomaly for 1 month in September. You've got more high pressure system there, which will give more of this cold polar air coming in there. This is the temperature. If you get that anomaly, what you will expect is more cold air coming in here and more warm air there. Warmer than normal there and colder than normal there. Okay, so just in terms of what's happening. These are the wind anomalies, so we're getting a more northerly flow there and a weakening of that here in terms of what's going on. So this is sort of the hypothesis that this may be contributing to this beyond what's happening just in terms of clearer nights. Recent events show this sort of process happening too, in terms of the pressure anomalies followed by the temperature anomalies, in terms of understanding this. So it's going back to this idea of understanding from a synoptic sense what's going on, and then trying to